Okay, this is the fourth coursework for CTR07104, Structural Calculations and Written Report. This is worth 15% of the overall module. And the module brief looks something like this. It will be presented on Thursday the 18th of April, and it will be a final submission date of Friday the 10th of May. It will be submitted online on Moodle, and again it's worth 15% of the overall mark. We'll be doing a simple beam analysis, and here's the geometry here, and the material will be timber C16 plus, and there's the dimensions of 245mm by 45mm timber by 3 meters and 50mm in length, simply supported with cantilevers at either side. The loadings will be UDLs on a partial UDL at 3 kilonewtons per metre and point loads at 9 kilonewtons. We've done this coursework in such a way that every student has a different load case scenario, so therefore your results will be totally different from each other, and then you'll have to write about your understanding of what's happening within that beam. I will use, for example, I'll pick one at random, A4. A meaning step 1, I will have partial UDLs, one at either cantilever, and 4 is point loads, again at either cantilever. Step 1 is worth 7.5% of the overall module. We're going to run the calculation tool. I'll give you a demo of that just now, and again I'll do this demo in class as well for the beam as described above. Report the support reactions, so that would be the simple support reactions. Report the shear force diagram, report the bending moment diagram, and report the maximum deflections, and show the diagram for deflection. Step 2, again, is worth 7.5% of the overall module. Rerun the calculation by adding in the additional point loads, which are 9 kilonewtons each. The technical writing exercise, discuss the changes to the beam when you add in the additional point loads. So that would be the initial bending moment diagram and how that changes, and the shear force diagram and how they have changed by adding in the additional point loads. It could make it worse, or in actual fact it could make it more preferable by adding in the point loads. Again, you will have to look at all the results and discuss your understanding of that. So this is actually testing not just your ability to write a good written report, which Dan Ridley Ellis has taught you, and Juan was teaching you how to present structural calculations, but it's also going to test some of your understanding of engineering principles, which is taught to you in BSEN 07103 by Wojtek and Juan. So this is quite a nice coursework. So I'm going to run Tech on TEDs. Again, I'll demo this in class as well. I've got my TEDs opened up. I'm going to go New, and then when I'm presented with New for the new calculation, I'm going to go 2D analysis, and then we'll go 2D analysis, and we'll just run that one there. Perfect. Let's get my sizes up. Now, we always start node 1 at 0, 0. The software won't like it if you don't start it at 0, 0. My second node will be 0.525 and up 0. And my next point will be 2 meters, 5 to 5, up 0. Then it will be 3.05, up 0. And now, of course, I want to hold point number 2, or node 2, to be fixed horizontally and fixed vertically. And we can see the icon is a little triangle there. Now, my next node, number 3, I want to fix that vertically, but I want to keep the horizontal free. So we've got a roller support there. And the purpose for that will have been explained to you in other modules. But for just now, take it as read. This is exactly what you're going to do. We'll go to Materials. I'm going to select the arrow key, go down to near the bottom, and it's Timber EC5. I'm going to select C16 Plus, which specifies essentially UK timber. And then we're going to go to sections. We'll select section. We'll say timber. So we'll select timber. Count 1. That was a 45mm by 245. Press OK. We'll go element. We'll go node 1 to node 2, node 2 to node 3, node 3 to node 4. That's more like it. And then we'll go member design. We'll press the 3 buttons at the bottom. We'll start at element 1 and end at element 3. And we can see that nodes 2 and 3 have been pre-selected by the software because that they already are aware that it's supported at those points. That's perfect. We'll just press OK to that. Now loading. Now I'm going to select self-weight off. I'm going to turn permanent loading off as well. I'm only going to allow imposed loading to be shown. Pardon me. I'm now going to move my cursor over here and select the imposed load at that corner. You'll see why in a second. Sorry about that. Now, I'm going to put some loading in. I'm going to go element, because I've got 3 elements there. Element number 1, imposed load, and it was 3 kilonewton meter per meter. Double check. Yes, it is. Then element number 3, 3 kilonewtons per meter. So when I've got this selected here, we can see that I can visually show my imposed loading. If I had permanent loading selected, which I don't, you would see that there. But if I go back to imposed load, so that's exactly what I want. I'm not going to have any load combinations, so I'll leave that just now, and I'll go straight to my results. In my results, we can see different diagrams. We've been asked to report on the support reactions. And we've got global reactions down here, and we've got node 2 and node 3, and we've got loading of 1.575 kilonewtons at both of those nodes. That's our reactions. We'll put that out in a report in just a minute. We also want to report the shear force diagram. Well, this here is your shear force diagram for this particular beam. We've got a bending moment diagram. This is our bending moment diagram for this particular one. And also report the maximum deflections and show the diagram. This is my deflections for this beam's diagram. Now, if we go to output, we can actually turn on and off various things. So let's do that. Input geometry, sketch. Loading, we'll do a sketch and a table. Warnings, nope. Total deflections, yes, we'll have a sketch and a table. Node deflections, no, we're not interested in those. Total node reactions, yes, we'll have those as a table. reactions, we'll have that as well. Sketch and reactions. Element, end forces, nope, not interested. Moment and shear envelope. Deflection envelope, axial deflection. Moment and shear, deflections, axial deflections and forces, axial forces. So we can select various things. I'll allow you to select the ones that you want, as long as it complies with what I've asked you for in here for step 1. We'll run this calculation. Go back here. Run this calculation. And you can see that we get some, or if not all, of the things we've asked you for. Now, an easy way to extract this data into Microsoft Word is fairly simple. In here, just Control A, select all, Control C, copy all. We'll go to Word. We'll go to a Word document and I'll change screen. And we'll go File, New, and Paste. And we can see all those diagrams and tables that I've selected. You could either select more or select less, depending upon your understanding of what we've asked you for in the project brief. You would only include the ones that we actually need, and then you'd include that in your written report. Now, this is not a written report. This is what you see just now is purely an output of the software. You will have to include this within your written report in the manner to which you were taught by Dan Ridley Ellis on how to write a good report. Now, this is step 1. Step 2 is to rerun the calculations by adding in additional point loads at 9 kilonewtons each and write a written report discussing how that changes the beam scenario. My example was A4, so A4, so 2 point load on either end. So I will just change screen, rerun this calculation. That was right click, press rerun, and bring it over here. I'm going to go to loadings, and I'll go nodal load. I'll add one in, node 1. That will be imposed load, and it will be vertical direction of 9 kilonewtons. And I can see that's shown there. And I'm now going to have a nodal load at 1, 2, 3, 4, 9 kilonewtons. And then go to my results. I can have a look at the that's been added on. Go to my results, and I can see there are differences there. I can discuss those differences. My reactions are significantly heavier from what they were before. Well, in actual fact, they're 9 kilonewtons heavier in this particular example. My shear force diagram is significantly different as well from previous, and my deflection will be significantly different as well. I can then go to my output. I can output the things that I need in this scenario. Press run. And I can now finish off my written report as it's been asked for here. Please use your understanding of what's been taught to you by Dan Ridley Ellis in the written report, and also what's been taught to you by Juan on how to present structural calculations. Also bring in your understanding from CTR07104, which is the module that Wojtek and Juan teach on, I think it's basic principles of engineering, where they're teaching beam analysis and shear force diagrams already. Is that you're looking at your understanding of what's happening to this beam when you add UDLs and then point loads on top of UDLs. Thank you very much.